Hello, in this video we will show how to implement pairwise mean comparisons in ANCOVA using R. So we know that ANCOVA is very similar as ANOVA. ANOVA is analysis of variance and ANCOVA is analysis of covariance. Because in ANCOVA, in addition to the categorical variables for the treatment groups we are interested in, and then also a continuous variable or several continuous variables called covariates. So we include covariates, this continuous variable, with categorical variable in ANOVA function in R. So this is called ANCOVA. And after we have got the results of the ANCOVA, which means their old treatment group mean value are the same or not, after controlling the covariance effects. So if we say got the results that say the ANCOVA is significant for treatment groups, which means not all the treatments have the same effects in the experiment after controlling the effects from the covariates. But we do not know which group is different from any of the other groups. So similar as ANOVA, we can do multiple pairwise comparisons for the mean between each pair of treatment groups. So next we will show example. Say there are four treatment groups with a different dose, 0, 5, 50, and 500. And it also has a gestation time is covariate in the data set. And the dependent variable is the mean birth weight for the litter. So we will show how to do ANCOVA and how to do multiple comparisons in RStudio. So first, we load library multcomp because the dataset called litter is inside this package. And we show a dataset called litter. So this data frame is quite simple, with a dose is a categorical variables, which is a factor because we have only seen the first 6, so dose is 0, and there are more observations with dose 5, 50, and 500. This is categorical. And weight is the dependent variables we are interested in, and just time is a continuous variables, act as a covariate. Then, for example, we can show some information. We load dplr package because we will group litter data frame by dose because this is a factor or categorical variables. Then we use summarize function from dplr and show how many observations in each group and their mean value for the weight and standard deviation for the weight. So for each group by dose, their observations and mean value and standard deviation. So it's quite obvious that this group has relatively higher weight than other groups. But this summary information is not controlled for continuous variables. This only show the mean weight value, but we do not know this weight value comes from those or comes from other continuous variables. This is the combination of all the other independent variables. So next we can implement an ANCOVA. So ANCOVA uses the same function as ANOVA, called AOV in R. Then we run this function AOV weight. Then on the right side of this tilde, we put just time first, because this is a covariate or continuous variable. Put first, then dose is categorical variable, and this is a factor for the treatment groups in ANOVA. So this function will know this is the categorical variable for the ANOVA, and this is the covariate. So this is the first variable. Then the result shows that both just time and dose are significant. So dose significant means the treatment groups mean value are not the same after controlling the effect from just time, right? Then after ANOVA significant, so which means that those treatment groups are not the same, even we have controlled effect from just time. But we do not know each pair. If we compare each pairwise, they are different or not. And with this package and this function GLHT, it's possible to compare pairwise treatment groups. Also, we can do some a little more complicated comparison. For example, we want to know the no drug group against other 3 drug groups, because the drug dose is 0, 5, 50, and 500. So only one group is no drug, and other 3 groups have drug, right? So we can make a comparison for this kind of comparison between one group with another 3. So we have to put the scalar for the comparison for this group is 3, and other is minus 1, minus 1, minus 1. Right? Because this is called, you have to get a summation of all scalar will be 0. This is the requirement. So we create a vector called rbind, and with the label no drug against the drug, and with the C combine these 4 values together. So we do this. If we show contrast, there is one row observations with 4 columns. And next, we will run function GLHT for the fit. Fit comes from the ANCOVA we have done before. And with this option, linear factor, MCP, then those equals contrast. Those equals contrast. So which means we have to test these categorical variables for this group factors, and because those is a categorical variable with 4 treatment groups, and this contrast include these 4 scalars, so this will be indexed for each treatment group one by one. Run, and the summary of these results will show this p-value. So this comparison means no drug against the drug. The hypothesis for the null hypothesis is 0, which means we assume this comparison is 0. So they have the same, they have no difference, right? So this is null H0 assumption. It's null assumption and null hypothesis. Then the results are, if we assume this is true, we get a very low probability. So this p-value is about 0.01. It's much less than 0.05. So which means it is significant, and there's a t-value. So this result tells us we can relatively safely to say that no drug treatment group has relatively higher mean weight in the dependent variables after controlling the effect from this just-time covariate than other three groups with drug. So we say again, the result is conclusion can be made like the mean weight for the no drug group is relatively higher than the groups with drug dose after controlling the effect from just time. So this is the pairwise comparison in ANCOVA. Although this comparison is relatively more complicated than a simple pairwise comparison because we use 4 scalars. So if pairwise is only 1 and -1, right? The other 2 can be 0. Thanks for watching.